Good morning or afternoon, everyone. Thanks, Nicola, for the introduction. So I'm Daniel. I'm your host for the webinar today, and I will also facilitate the Q&A at the end of the webinar. I have taken over the TDS webinars, at least for now, from our previous host, Namir, who would like to thank again for his work over the last 3 years with this very successful series of webinars. So today's webinar is about the moisture management in timber, and as we all know, it's a quite popular and important topic, and I'm really looking forward to hear what Bjørn, our speakers, will tell us. Now, before we go into that, this is obviously the first webinar of the year, with many more to come. We have a few orders lined up, with the next one being on the 21st of March, where Rotoblas will talk about the design of engineered wood screws and how to use the screws with the ETAs, the European technical approvals. Other webinars we have in the pipeline are about good and bad connection design from Pierre Kinwell from the University of Auckland, and John Goldsworthy will talk about lessons learned on mass timber projects. Announcement will be made very soon. If you have any topics of interest you are interested about, please get in touch. Or if you would like to share your experience, also get in touch. We would be welcoming you on our webinars. As Nicola was saying, the webinars are being recorded. You can find them on our TDS webpage. Now, I would like to thank, obviously, the TDS committee for supporting these webinars. It's the 4th year we are running them, and we will continue running them as long as you join us. And the numbers are pretty good, so this is a very good sign. I would like to thank our sponsors, FutureBuild, MyTech, Simpson Strong Tie, iBuild, and Rotoblas for supporting, and Ixlab for supporting us as a society. Now, before I go into the actual detail of the webinar, I would like to remember all TDS members on this call that we have an AGM on Monday, the upcoming Monday at 3 p.m. I really would need your support in joining us to get the quorum and make our election and AGM meaningful. And Nicola will pop in a link to the registration page. So if you're a TDS member, would be really great if you could make yourself available for half an hour on Monday, the 26th at 3 p.m. Right, so to today's webinar about moisture management on timber, we have Bjørn Stankowitz, who is joining us. Now, Bjørn is a structural engineer and has an intense background in timber. He's a carpenter by trade and has then studied timber engineering in Germany. I know Bjørn since about 15 years. We have both started our career in the same company, Italy's biggest glulam manufacturer at the time, and we now both work in New Zealand, making sure that timber design is done properly. Bjørn is obviously specialized in mass timber design. He's also technical director for timber at Engco, and is also technical manager at Timber Unlimited. He's working on several projects, but the most important ones are a moisture management guide, which is obviously aligned with today's seminar. He's also working on recommendations and improvement on our new timber design standard, NZS AS 1720.1, and establishing an expert working group on the topic. And there's several other projects he's working on. The webinar today discusses moisture management in timber, from the basics to first principles and steps in design for durability. And the webinar will reflect Bjørn's experience over the last years overseas and in New Zealand, and hopefully provides you with learning the essential strategies to enhance your approach to durability in timber constructions. During the presentation, please pop your questions in the Q&A session, and then we will try to answer them later on. Last thing to mention, Bjørn has tried to make this webinar a bit more interactive. There's a QR code on the screen. So if you just scan that code, you can then answer some of the questions and queries he's answering, which provide him some feedback in terms of this seminar and future events. Also because there will be a CSOC and TDS roadshow later on, which Bjørn will then introduce. With that, Bjørn, over to you. We are really looking forward to your presentation today. Thank you.
Yeah, hi and welcome everyone. And thanks, Daniel, for the introduction. Welcome to the topic today. You heard Daniel announced that if you would like to get your phones out, scan the QR code. And one important thing for the housekeeping is the Q&A will have to be on the Zoom link that you clicked, and only the polls that come up on the phone, please answer only those. So otherwise we're getting mismatch in QA. All right, let's kick this off with our topic, moisture and mass timber. So first question that should come up on your phone right now is, what is your interest in moisture related questions to timber? So I'll wait a couple of seconds, and that gives you some time to put a few responses, and we'll keep going. So it's very interesting, mostly engineers. We've got some architects here, which is great to see, some supplier and some contractor as well, even some QS. And I'm happy to see that there are people out there that are interested in timber and want to, yeah, maybe add something to what they know already or know a little bit more about it. All right, you can keep going with this poll. We come straight to another question, which will work out whether this poll is working. So what do you think is your experience with compliance and specifications around mass timber? So scale of 1 to 5. 1, tell me more. 5, I have it all worked out and I'm pretty sorted. So give it a couple of seconds again, and then see where the audience is sitting, so we can dial a bit deeper in one or the other topic, and then make it a little bit more suited for every one of you. Don't think we will get all the people answering straight away, so we'll wait probably if we have 70 of you put in your votes. And this is a broad field, and I see we've got a few of you that have just recently started, probably picked up your first mass timber project, or even just want to know what's the story about timber and moisture and how I can address it in the future, which is really good. And I hope I can add a few things for you guys. But yeah, keep in mind that you probably know quite a bit already. So we're stopping this now and moving into the actual presentation. Is moisture actually here? Well, yes, and so are we. So in most maps, New Zealand actually disappears, but trust me, there is moisture out there. And depending on from which angle you look at it, it is either beneficial and you need it to stay afloat, while others probably just ignore it and come back, oh mate, it's just a bit of rain yesterday, but the timber is sweet ass. So with that in mind, moisture is actually there. And we've seen it in floods, in endless days on rain on site. As well, it reflects in the moisture content measured in mass timber that we observed over the time of the years. So coming to a question, or more a sentence you probably want to think about the whole presentation, and even in your designs, is there are things out of our control, but they are predictable. And they're unpredictable, but in our control. So moisture is a bit like that, and so are the effects of the moisture, and so is everything around mass timber. So let's add all these things together and start with a few slides from before and after COVID, I call it. But we don't really want to start like this, but unfortunately, these are a few shocker slides, I call them. Looking at mass timber projects where, unfortunately, the moisture management hasn't gone the way it was agreed, or the rain actually came in and it was unpredictable, and it was out of our control because the area was too big. And then I remember a phone call of a builder asking me, what do I do with this jib? It's been sitting out in the rain for a while, which has triggered in return a whole lot of questions coming after that, because the timber around it was actually needed fiber saturation, and therefore prone to sag under the additional weight of the gyp, saying that the gyp ended up in the container outside of the window. So again, moisture in CLT buildings, we've got a floor above, and we've got obviously some penetration, some openings, and the ends of a building are open. Driven rain can get inside, and no one is taking care of it. The floor just remains wet and moist, and leaving things on the floor, attracting moisture, or attaching screws and then snapping them because we've got expansion in the timber. More to that later. It's all the pictures we've seen in the last couple of years, unfortunately. But it doesn't come only to mass timber in terms of CLT. There's also glulam structures we're looking into, and one of the common details are dowel connectors. So they're easy to install, they are efficient, we know well how they perform. One thing we don't really know well how they perform, or it's hard to predict, is how much stress they cause when you put them in, the timber shrinks, and then the stresses can't get resolved. It's an item that we can't really quantify, and therefore need to do something about it. So it's a very localized problem that we're facing. And then there's the question about mold. Mold is everywhere. Mold is in New Zealand. Mold is in the world. It is in fibers, in spores, floats with the wind. And if it gets on your timber, it starts to nest down and discolor your surface, which is a really downturn when it comes to the end of the project, because stained timber, most of the times beautiful glulam is left visible, has to be sanded off, and that takes a lot of time, obviously. So something that came in just fresh out of the mail from overseas, from an old friend of mine. He's an assessor for damage in timber construction, and timber starts at windows. So for the architects in our audience here, it's not only related to structural items. Timber is also in windows, and depending on how we coat them or where we place them, it has obviously great effects on the durability of these. And then there's the other question, not a visible risk, but there is a risk, and which is the design. So just recently we had the changes in the H1 code, and the requirements for the insulation have increased. So a lot of clients do want to upgrade the buildings now. And if you have a concrete building and you want to upgrade this, where do you place your insulation? That's a big thing. So you place your insulation on the inside without a moisture barrier, a vapor barrier, and you create a dew point. You create condensation and continuous water leaking in your structure. So all these items to be thought about. And then comes the question, I often get called at Timber Limited and get asked, but I thought we had treatment for all that, and timber will last and it's durable for 50 years. Well, the durability is just a name we made up, basically, for something that we created. And we're trying to do this in New Zealand with treatment, but to really do something about it, we need to understand the timber better. So let's drill into the actual timber for a moment, just to get the beginning of it, so I don't lose everyone from the start. We've got obviously the forest where our timber grows. Then the important point for us is we get the cutouts and the sections that we get out of the timber. We've got several directions. We've got radial, tangential, and longitudinal. And then the timber itself contains out of a very complex cellular structure in fibers. And that is the particular reason timber behaves the way it behaves when it comes to moisture. When it comes to moisture, timber moves. And this is out of our control, but it's predictable, which is temperature and relative humidity. We've got data from NIWA around New Zealand, and we do have all the information around this. What's unpredictable but in our control, on the other hand, is the rain, and what we're really great in, everyone, is the communication. So looking at those items here, we can predict and control in a way if we understand how timber moves. For that, we can, on the bottom left, you see a diagram to estimate the moisture content depending on average temperature and humidity. And then top right, you see how the timber actually moves depending on its moisture content itself. And at the bottom right, you see how it will move and how this could actually cause stresses if you constrain them. So let's talk about the cellular structure of timber a little bit. We've got timber cells, and in the timber cells, in green timber, when it comes out of the forest, we've got free water inside the cells. It's basically fully soaked, and your timber is the heaviest it will be. When it dries down, it needs quite some time to get to fiber saturation. Beyond fiber saturation is when the movement in timber starts. Between fiber saturation and dry, which we define in different percentages, you'll see that later, we have swelling and shrinkage. And on the left, you can see if we only come to bound water, which is just in the cellular structure, the timber actually moves from kiln dried, which is the KD, to oven dried, which is 0%. So to make it a little bit more visual, I thought we just go into a thing that we all experience. We've got free water versus bound water. Free water, take a sponge, fill it with water, squeeze it, and all the water that comes out is your free water. What you then face is, if you leave it for a while, is that the sun and the air will dry this sponge out. Only then is when the bound water can evaporate. There's no mechanical way to get this out of the timber or the sponge. And at the end, you probably have seen it. If you go on holiday, you come back after 3 weeks and you forgot your sponge, it'll deform. So nothing else happens with timber. Timber cups, bows, crooks, twists, cracks. So there's quite a few effects on timber due to moisture, which I'm not going to go through the whole lot. You can read this up in the New Zealand Wood magazine, and the guideline, and Buchanan has written it. It's very thorough. So if there's anything that you're unclear about, go through that. It's well recommended. So focus and aim for today: spot the danger, specify the right thing, communicate the problem, and provide solutions. And on the other hand, understand timber. What's the moisture movement? What is decay? And what is mold? So first of all, there's a lot going on, and we said timber moves different in different directions. What do we need it for? We need it for bridges to find the for tolerances. We need it in houses for connections, and we need to estimate how much a multi-story CLT building is actually shrinking over its time. So all that is embedded in these values, and every timber has a slightly different movement. Now you see every change of percent in moisture content has a factor, has a coefficient. This coefficient can be multiplied with the width or the depth, and you get your estimated end section that you're probably dealing with in your design. Now, one thing that you probably hear today as well a few times is EMC, which is the equilibrium moisture content. It's basically the moisture level where timber neither gains or loses moisture, and it's depending on relative humidity, temperature, and as well the density, because the density defines the fiber saturation. One thing to be aware of, and you probably heard this, and I'm jumping a little bit forwards here, reinforcing timber. Some of you might have heard it already, and there are some thoughts around whether it's actually beneficial to reinforce timber against moisture, because at some point the stresses are even too high for the reinforcing. However, in recent test, it shows that if your timber moves between 6 and 12%, 6 already starting to get critical, 12 being an absolutely doomed scenario, and you have your connection installed, there's likely something happening to them. So is it to the timber. Some of it might be at 6% only visual and not appealing, and you need to fix it, which is referred to checking. And then it becomes structural, and then it becomes cracking. So prevent the splitting is one thing. So if you got a glulam floor and you got these spline joints with plywood, just think one moment about how you fix them. If you look at a small section, like one of these elements is 650 wide, talking about 1.6 millimeters of expansion or shrinkage, depending on obviously how you deal with the moisture inside. If you don't care and you just pretend, well, timber will handle it, you're ending up at almost 5 times that. Over the whole width of a 10-meter building, this could end up as 84 mil of shrinkage and deflection and swelling. So it's quite a significant force. And if you think about your concrete slab that you're designing, when would you put a free joint? When do you put a saw cut? So timber is nothing different. It creates tensions and stresses, and those have to be released. So one suggestion is, if you don't really have a good handle on how the timber behaves on site and who's doing it, do not glue the joints, but install it with screws that can yield. Coming to preventing of splitting, one very important point is when you use dowel connectors, is consider the construction sequencing and find out when the builder will install these and what moisture content the timber would likely have. So probably it's better to actually say we're installing just a couple of them, here pointed with the actually bolts instead of the dowels, and those might be sufficient for construction purposes, and you release all the stresses that you would accumulate if you put all the bolts in, the dowels in. So try to avoid this stress due to shrinkage, because you put too many connectors in during construction. Think this through, talk it through with your contractor, and prevent those damages that are structural and often imperishable. Now, moisture defined for structural designs is a thing. So there's 3603, 1720, then there's a durability, then there's 3604, and then there's the councils. So everyone is bouncing some numbers around, and council allows you to line the walls at lower 18%. Well, this is basically related to light timber framing. What happens to mass timber at the end of the day? Mass timber has way more mass itself, and therefore stores more moisture. Is that okay to line at 18% as well? Questionable. One thing to think of is also that the old 3603 defined dry timber 16%, where the new 1720 defines it at 15%. And everything beyond 15% requires a reduction based on clause 2.4.2.3. Yes, we love these clauses in 1720. Now, Nelson, Pine for LVL have issued their own factor, because LVL is a little bit different in terms of how it behaves. So therefore, if you look out for LVL and you want to calculate that, go to their guidelines or the other LVL manufacturer guidelines, whoever you use, and try to seek that information. Now it comes to the very important point, the specifications. We all want to specify timber, but what do you really specify in your designs for the moisture content of your timber? So this should be coming up as a poll, and I'll be really keen to hear what you've been doing in the past, or what you, based on these random numbers coming up there, would consider to be a good moisture content to use. I know it's not very easy because some of you might not be totally familiar with it. So just take a guess, and those who have dealt with it, I'll be really keen to understand what you've been using. and what you thought was right and what you experienced was right. So we've got a few answers there. We're just going to move forward. 10 to 14 is the prime answer, 14 to 16. And fair call, a lot of you need more information, and that's correct. What am I looking at? What depths, what time of a year? At the end of the day, no one of you is right and no one of you is wrong, because the answer to this question is we're all right. And we need to understand more about the material we're using and the state we're going to use it for. So 10 might be too low, 20 might be too high, but for other constructions, 18 to 20 might be just right. So quick story here. This is how you could specify the moisture content and tell contractors and suppliers what they should be doing to make sure they get it right, and that you as an engineer are happy and you follow the rules and you can tick the box. But don't fall into the trap. I've always done it like this. So this is a trap I actually personally trapped into, and Daniel would understand it as well. In Europe, we deal with lower moisture contents in timber. The moisture content in production is lower, and also we have a different environment. So ultimately, we treat the timber slightly different over there and handle it, and therefore that has an impact on it. So I got contacted by supplier and contractors. How do we achieve this? Is it actually reasonable? And then looking into a table and looking at New Zealand's different climate zones, and we all know New Zealand is not too cold but not too hot, but it's got some difference in moisture in the air, in the relative humidity. So as a matter of fact, the equilibrium moisture content in timber, in mass timber, can sit anywhere between 12 and 21%, depending on where you are in the country, when you build it, and obviously then depends on the transport as well, because time is a factor as well. So if you expose it longer, it sort of balances out. But how is that comparing to the overall average temperature and relative humidity? So it's 12 to 16% if we take the whole average over a year. So it highlights to you that we actually need to look at the seasons more directly and talk to the contractor and the developer. When are they likely to kick off this job on site? When can the supplier supply you the COT? There's a lot of thoughts that has to go in here, because you're not just ending up at 12 to 16%. You can, as you can see from the top, end up at 12 to 21. But that doesn't encounter the fact that we have a lot of rain in New Zealand as well. So there's a lot to add to this. If you don't remove the rain and you let it sit on the construction, obviously has an impact on top of the equilibrium moisture content. So anything you add on top of what's there already will make it worse. And this is where we're sitting. So when you come to your specifications, what can we do? We can communicate, we can define things, and we can talk about them. Define the required moisture content, communicate with supplier, and get everyone involved from early on. Because you can see between construction and in service, it can be already a difference between 9% if we had a HVAC system and we assume the one of the average conditions. So 9%, we saw that earlier, if we're using glulam, could already have an impact and starts checking of the timber, or even structural cracking if we have too many connections installed. So this should ring your alarm bells and say, look, this is too much, we need to bring it down. But how? We really jump into the next topic straight away, because also related to moisture content, obviously. And I want to introduce you into the Mythbuster mold, which is not structural, but more visual. So depending on the relative humidity, mold grows, and the temperature is required as well. And then it requires oxygen, and then it requires a layer of organic material. So at the end of the day, there's more factors than just the moisture content. Because at the end of the day, if you look around your house, I hope you don't, but sometimes it happens that we experience to have mold even on window sills. And window sills or steel beams or silicon don't really have a moisture content. So why is the mold growing? Well, the mold is growing because it has an organic material to thrive on, to grow, and the environment is has the correct conditions for it to grow. So only happens that the mold is there and sits on the surface. But does mold destroy the timber? Well, no, it's superficial. Decay does. So that's one of the other myths that we've been lately hearing a lot. And a lot of suppliers are trying to educate their clients because they are aware of the issue. They know the products. They know how to get around it. So here message, talk to your supplier, and they will have a good guidance on how you can actually avoid these things. And at the end of the day, decay destroys the timber, but decay does start very later at a higher moisture content that you hopefully do not get to the point that you actually have to discover it on site, because it's sitting around a fiber saturation. And as we saw on earlier slides, we don't really want to get there because that's when the timber expanded the most. So if you look at your diagram, so why it's 19% on timber and why it's been communicated is because if we look at the relative humidity and a rough temperature in this previously described chart, we're ending up exactly at that point under the perfect condition for mold growth. So that's why it's not the timber that creates the mold, it's the environment around. And that's the important part to understand. And once you understand that, you can influence it and you can control it, and it's predictable. Does rain make the mold worse? Well, actually, yes and no. Well, puddles are blocking off the oxygen. Remember, mold needs the oxygen to grow. And once the water is evaporated, just make sure there's a lot of airflow, so you don't have a standing air that the relative humidity can't go up. And once you got that, you're avoiding the extra mold to grow because of rain. Another thing to think about. And you can't remove it. It affects the glue and everything. We heard it, and thanks to Redseg and Timberlab for this one here. In most cases, you can. It's obviously depending on when you remove it. If you remove it early and substantial, it's no problem at all because it doesn't go as far in the fibers in the cellular structure. So talk to your supplier, get some coatings or a maintenance schedule or a installation schedule, and get these things sorted. Coming to the other one, it's the monitoring and protection. What can we do on site to actually shed the timber, the moisture away from the timber and keep it away, keep it dry? Membranes. We've all been seeing them. Timber buildings are not brown anymore. They're starting to become red and white and blue on the outside. And this is good because these membranes are able to breathe. They seal from the weather, but they're able to breathe. So any trapped moisture inside the timber can migrate through these membranes and doesn't cause any damage further on, and the timber is able to dry out. We can also use these to protect floor joints. Now, why am I showing this? This was actually a building that's been monitored perfectly and has been looked after, but one room was forgotten. Just for some reason, it was a bathroom somewhere in the inside of the building. But we had membranes just glued over the lap joints. And you can see how just a couple of boards beside it, the moisture content sits at 26%. And below it, I mean, there's some migration and water gets to the joints. So obviously rises, but it doesn't get to a point where your alarm bells go up in a way that you say, okay, we're having a huge problem here. It's sitting at 18%. That is borderline. We don't want to really go further than that, but we don't get into a point with COT in this particular location where we have troubles. And on the other hand, again, look at the blue facade, 14% moisture content. That's behind a facade that's been sitting in the rain. So the evidence is there. It's working. Use it. Then there are the other things we can use. We can obviously apply CCA in boron treatment. We can put coatings and sealers on. And on COT, the question is, do we want to put coatings and sealers on? I mean, if we look at the lamellas and how they swell and shrink and how the gaps are opening, is a sealer really keeping the moisture out? And then it comes to this example for temporary coatings on CLT. Maybe at the beginning it does, but when you expose the timber to a lot of sun and it dries out very well, the gaps between the lamellas will open, and that will cause the coating to crack, and potential water can get in. So talk to your supplier of the material and see if they got a different formula for the environment that you need. Maybe there is another additive they can add to make it more elastic and it doesn't fracture. Another thing, very easy method, is to keep the water away, but cover the end grains when there's rain forecasted. So we know that. And another thing is we do tend to leave these covers on for a long time. If something happens inside, builders walk away. But when there's no rain, we should take them off and get the sun and the airflow dry out the timber itself, because that's what it's got. And then the easy ones we can specify and get our construction team around. I know there's several teams already absolutely onto it in New Zealand and came up with some brilliant solutions. One of them is the squeegee. I mean, that's probably the favorite of every timber builder. But it's probably not the most effective to get it all off. So something long-term is some temporary drainage, or even to hoover it away. And then you come to the actual point of, we want to measure the moisture and see where it's going, to keep control, to actually make sure that our specifications and what we define to be the limitations and the boundaries are met. So you create these big tables, and you get a structural engineer or someone on site to run around the big mass timber job or your residential job every week to tabulate this and to do your QA. This is one way of doing it. And what you want to tell them is where to measure, because they can measure everywhere or anywhere, and it probably doesn't really mean anything to you. So Swedish wood and other guidance saying 300 mil from the ends is good for timber. So is it in New Zealand for timber assessment of drying timber itself. So it's well aligned. And the depth suggested is usually two depths. One is if you, for example, have CLT, you measure at 6 to 12 millimeters, and you measure then in your second lamella, because that gives you an indication, is the panel dry from the inside? Is the moisture in the panel just surface moisture? And will some dry days actually take the moisture away? And the other thing you can do is you install, sorry, I jumped one slide here, is install a moisture logger that gives you live data. And we've been we've been installing a couple of these in numerous buildings in the country over the last year with Timber Unlimited, and we're kindly given access to some of the sites that also used it. So we've got a really broad picture of where the moisture is heading. And yes, there are problems and difficulties to look at it with LVL, because LVL and moisture, as you know, probably is different because of all the glue inside. So there's correction tables for that from the manufacturer, from the supplier that you would need. With these automatic live and calibrated ones, it's still a little bit difficult. So be a bit mindful around this, but talk to the supplier as well. They might give you some updates on changed settings in the future. Now, if we compare this to what we actually discussed before, the prediction of where we estimate the ECM to be, and we look at where we are right now in summer, we predicted 12 to 15% moisture content. And if I look at one of the graphs here, we're sitting somewhere around the ballpark. So all of them are sitting in plus minus a little bit around it. And you get a really good understanding over the last months how the timber is behaving. And you see the difference between relative humidity at night and day. Those are the little wee up and downs, and it makes total sense. And the table that I introduced you earlier that you can use for your specifications will give you an indication of where you're sitting. So actually a really good tool. So now it's probably time to introduce you what you can actually do to make timber actually durable and enhance its lifetime. First thing is keep the moisture away. We know all that. But let's start for the architects with a cladding, with a facade. There's an example as well from overseas where we do use these glue laminated boards. This is spruce in this case. And if you look at the detail, you can see the flashing is really tight and the gap is very small. So any water, any splashing water will be reflected straight into the end grain of the panel. And therefore the moisture will get sucked right into the facade. So trick around this, create larger openings and make sure there's an airflow. So if there's moisture, the air can actually circulate and take that moisture away straight away. Another thing, you've seen this picture before, is a primary beam and secondary beam connection left open on side. You have in grain running into the main member, and therefore your high risk section of your member is exposed. Moisture can get sucked in like a straw. What can you do? Something very simple. This is what I've been given also from overseas. Just add a strap of membrane on top and avoid the water hitting actually these gaps and getting actually sucked in. And you can take it away afterwards, or you can leave it depending on your roof buildup. So avoid cyclic swelling and shrinkage, and then prevent internal stresses. And I love this one in particular. It's a balcony, and who of us hasn't received the call from a client? I want an internal gutter, and I don't want to see my downpipes. And the architect says, "Brilliant idea! I love that." The engineer can integrate it in the wall. Something happens. We have these little things, earthquakes they're called. They rip pipes apart, and then this is the result. So no treatment, no nothing would actually prevent you from that, because it's affecting everything around it. The other thing which we have discussed before was the not visible but still a risk through to design, and just by adding a vapor barrier inside on the inside on your warm side of the building, you're reducing the dew point, and you're reducing well, you're not reducing the dew point, you're reducing the actual moisture that is penetrating through this layer. So you still got a drying out time of 39 days, which is a bit too much, but you still see the difference if you look at it from the start. And if we as engineers and architects talk the same language, we can prevent these things early onwards. easy ways to do this is Woofy. There's plenty of consultants in the country at the moment that are really experts in that. And a very simple tool that I'm using is called Ubercus. It's in English, it's available in English. It's got all the materials set up. So you can build your wall up, find out, do you have moisture falling out in my wall or not? Need to talk to the architect. Is my stud actually affecting it? So we get a bit of conversation going there. And it's not that one is telling the other one what they have to do. It's basically understanding the same language and talk about it. So CSOC seminar, almost at the end of the presentation, was postponed to July. And I will present a few things about costs and moisture management. We'll go probably way more in detail than we could go today, and we'll actually give you some examples on how you can achieve good solutions that will actually help you to communicate to those who need it most, which are the developer. And that's eventually the link that we all seem to forget. If we need to talk to the developer, if we don't provide them with the right ideas, we're never going to get our specification pushed through because they're too stringent and hard to deal with. So talk from the beginning and get engaged. Now, a couple more sliders for you. This is a little bit more open. I suggest we give it 1 minute, Danielle, and you guys actually need to type in a few things. If you wouldn't mind to do that, that'd be fantastic. If there's any topic you'd like to discuss, if you can think of, oh, this would be really handy. Very important for us as an engineer, then let me know, and we'll see what it comes up with. I think we do not show these. We will show them afterwards in a final workout, as there'd probably be too many of them to actually discuss now. And once we evaluate them all and test them all, we can tell you what your feedback was. So by the way, I didn't mention it, none of these feedbacks will have a name to it. So it's all anonymous. So you don't need to fear or be shy. I'm sure you've got questions. I'm sure there's things you would like to get answered. And this is a bit longer one. So we wait a little bit more and see what the majority is coming up with. Right, we got a couple of questions. You can still answer those. Just waiting for a couple more, typing the last little responses. And then I'll move to the next slide, which will be all right. I don't want to cut anyone off here, but we need to move on. And this is something that we do for TDS. We really want to know what would be your dream topic that you want to know more in detail about. So TDS can actually look at this and say, look, there's interest in the country for certain topics, and we want to help to foster a good design. And if you wouldn't mind to pop in a couple of ideas for them, that would be absolutely great. I see we've got quite a few typing there. I know this is a little bit awkward looking at a slide and having silence, but it would actually help us a lot. So thanks for those who are typing in their responses. I'll move on with the slides. If you haven't been able to type them in, please feel free to actually put them in the Q&A later, so we will have the results as well. Some of them are here, more guidance, that's great. So some of them you can see, that's perfect. We'll work out the details later. In the meantime, there's a lot of literature out there to read. We're writing a moisture management design guide, but the three major ones you probably can use for risk assessment, things you can do on site, as well as remedial actions for moisture related damage, are those three here. And at the end of the day, timber cracks, concrete cracks, steel expand or contracts, and nothing lasts forever, or 50 years, how would you find it? But if we don't pay attention to the material, then in detail. So everything that's out of our control but predictable, and what's unpredictable in our control, is something we can address. And I'll say thanks for listening, and we'll be answering a few of your questions if there are.
Well, Bjørn, thank you very much. That was a very interesting talk. I have to say also your format with the slider was well received, I see, and it's a really good idea. And kudos on you for introducing this. I think we should rely on that a bit more often to make a rather one-way type webinar a bit more open and open for discussion. So thanks for that. There's a few questions coming in. Before I go through that, there were a few attendees who were wondering if you would be considering sharing your slides with the attendees later on. So if so, maybe you can adapt them as you need, and then we can send them through the registration link. So thanks for that. And a few people
I would probably have to ask, so I would probably have to ask, some of these slides are, not confidential, but I would have to ask the rights to pass them on, but I will do that, and then I'll let you know if we pass on all the slides or those that are able to be passed on.
Or a selection, of course.
Or a selection.
Yeah. The other thing, a few people might have confused the Q&A here and your Slido. A few other topics of interest were the coatings on connections, on fixings, which was a topic probably 2 years ago, but perhaps something to revisit moving forward. And another question or suggestion was the good detailing for durability. So I call it durability by design. So perhaps something we together with you, Bjørn, or Timber Limited could consider to do a specific webinar or more on that topic, because it's my take. We shouldn't just rely on treatment. We should rely on good detailing in the first line. We need several lines of defense. That's my feedback. Right, so questions are coming in. Bjørn, you did mention that doing the construction, you would use only a few bolts to fix the members together. Would you then essentially use bolts in the first place and then add the remaining dowels in the final as is condition when the timber has a lower moisture content? Was that your intention?
That's correct. That's the intention. So it's basically look into whether you need temporary propping or not. Sometimes we actually get away with the construction loads being rather minor, and you end up with less dowels as possible. You put the bolt in, you lock the structure, and you can move on. And that also creates obviously speed in construction whilst still providing the bracing and the structural integrity for construction purpose. It does require obviously some extra numbers of the engineers and extra time spent on that, but it's well worth it because you don't deal with all the aftermath later on.
Yeah. That's a very good segue into the next question. One person in the audience says, the contractor will very likely push back on a moisture content lower than 18%. I let you go into that in a bit more detail, but my first reaction is, well, we can go higher, but is the contractor then prepared to do remediation work if this really occurs for long term? That would be my feedback. But Bjørn, how would you approach a contractor who essentially doesn't want to hear about anything lower than 18%?
I think the approach is the same as you described, Daniel, but I would go a step further and actually get the client involved as well, because at the end of the day, it's the client deciding where the money is spent and how much they have to take out of their pocket to actually get this building alive. And if you hear as a developer, there are ways that cost you upfront a little bit to outweigh the risk and to outweigh the delays and to outweigh the additional cost with, so it be just sanding off mold, can take a lot of time, and time is a lot of money on site, and we know skilled labor is not everywhere available. So we do need to communicate that to the client, and I think that would be my answer. And if the client is willing to take the risk, and if we have a measure to prepare for those internal stresses, and if we're confident with it, we can deal and build around this. But the suggestion is stay lower and get the contractor involved early.
Yeah, look, I couldn't agree more. It's all about risk and making people aware and contractors aware. And I think contractors also have to come to the party. We're not talking here about 3, 6, or 4 houses necessarily. We're talking about mass timber. Yeah. Now, you did actually answer the question, but I still want to read it out. You just said sanding off mold. That was one question. Can you sand off mold, or is there any other way you can get rid of mold once it does occur? I guess this is referring to surface mold in this case.
Surface mold, there's plenty of options available. I'm not an expert in mold removal, but I have dealt with all the suppliers, and they are quite experienced with it on one hand, unfortunately, but fortunately for us, they know the remediation for it. And in most cases where it's removed early and substantial, there's no long-term visual damage from it. So yes, there are other ways. There are certain liquids you can apply, and you need to talk to your supplier because they use different glues, and depending on the glues, those liquids might actually be harmful for the glues itself. So every supplier will have their own experience and best practice, I suppose. So yes, there are other options.
Perfect, thank you. So there are a few questions about measuring moisture content with a moisture meter. So one question is, if you measure with your probes, obviously you have to punch some holes, would you increase the same holes over and over again, or would you move your probes into like a similar location but offset from the previous holes?
Ideally, that's the thing you should be doing, because you obviously know if you have a hole and it's not much, but it's a little bit of air that can circulate, it can take the moisture away, and your probe, the end of your probes might not touch the actual timber anymore because the timber might have shrunken away. So you're actually putting your small probe in a larger hole, and therefore you don't necessarily get a good connection, and therefore the electric transfer is not happening. So you get a misreading basically, or a wrong reading that will mislead you into a way that you probably don't want to see. One thing to say for the moisture management, it can fluctuate quite a lot, up and down, up to 2%. So therefore, pushing the levels to your limit and then measuring, you have to be mindful that the measured moisture content might actually sit slightly higher. And if you're already on the boundary of something that would cause you grief, you should ask yourself twice if you're still happy with it, or if you're not, do something. Drying it down is always another thing. You don't want to apply heat. You want to apply airflow to keep the mold away over time, because the relative humidity is rising just infinitesimal above the timber, and so you want some fans basically. Get this air moving, and until you got your windows in probably, and then good opening of windows and air circulation is the key to dry timber out and to measure it eventually then.
2 follow-up questions on that, Bjørn. Have you ever seen a moisture content increase if you use previously punched holes? For example, if there's any surface water trapped into the holes, is that something you have seen or something you would be aware of?
I would be I haven't seen it myself, and I think once you see actual water squeezing out of a probe hole, you should ask yourself, is it still the right location to measure, or should I just maybe move it slightly over to the side? So common sense revealing, and I think you will see that straight away. There might be a difference if you measure the same hole, there's no water coming out. So look, I would move over to another hole if possible.
Two more questions, one still related to measuring of moisture content. You did mention that you should measure at two different depths, one at 6 to 12 millimeters, and one ideally the second lamella when you have CLT, or it could be glue lam by the other material. How do you measure the moisture content deeper in the timber?
So you got these, you probably would have seen it. I can't go back in the slides now, but you probably would have seen it, and you can go through the slides. There are these sliding hammers, and they look, it's basically a sliding hammer with two larger probes on them, and these probes can be entered into the timber to deeper depth, and that's how you get to the second layer. So it's hard to explain it without a photo, but if you look up sliding hammer for moisture meters, you will find the exact tool that you need.
Thank you. And the things I would like to add here is, I think engineers who are working with mass timber should have their own moisture meter, and also contractors should have their own. And the second, these moisture meters measure current, and essentially how much the water can pass on the current between one probe tip and the other. Now you can imagine that if you treat your timber with chemicals, especially copper or other boron, it transfers more current. So there's factors which you should apply depending on the treatment and the material. And I understand that these values are normally available from suppliers, and they're freely available on the web, and they come also with some of the moisture meters. Is that, do you agree with my comments on that, Bjørn?
I agree with the comments. One thing to add, and if you measure relatively frequently, you want to think about getting a calibration pad as well, because nothing is really working well if it's not calibrated and you're 100% sure it's working. And the other thing is surface temperature does affect the reading quite significantly. So what you probably want to get also is one of these infrared thermometers. They're quite cheap, but that allows you to dial down or up your calibration itself. Most moisture meters these days have it. The digital ones, the non-digital ones, I'm not quite sure if they do. There's some correction factors you can apply to those afterwards. So some post-processing required, but in general terms, the temperature, especially in winter or especially in very, very warm areas, should be adapted and adjusted.
Perfect, thank you. Very last question, Bjørn. There's a question which is referring to timber poles, but I think it's more general. Does the moisture ingress usually happens on either end of the pole, like at the end grain, or is it affecting all the member as such? It's perhaps worth mentioning a little bit on the end grain and moisture.
I think so. The worst, or the easiest part, the easiest way for the water to get into the timber is from the end grain. So it's basically, if you look at a tree, this is how the tree works. It drives the timber up the trunk to grow up the leaf. So that's the same for your member. Any water will always enter a member from the end easier than from the surface. Obviously, over time, it will also migrate through the sides, but the worst points are the end grains. And those are the critical points if you are on site to protect, but also in your design to protect. So if you've got an exposed glue lam and you've got an end grain sticking out somewhere, like the end of a member, consider to put a capping over, or just a sacrificial piece of timber that if you see it's rotting, you just take it away and put a new one on, because that stops direct moisture from penetrating into the end grain. And that does a lot for your timber to keep the durability.
Perfect. Thank you, Bjørn, for all your wisdom and for answering all the questions. That is it for us today. On behalf of TDS and the design community, thank you very much, Bjørn, for taking the time for this very well-prepared and well-presented presentation. And thanks for all attendees for joining today. And I'm looking forward to see you in a month's time in our next TDS webinar. Thanks again, and goodbye to everyone.
Bye for now.